Let's take the same waveform that we did in the previous video, with the only difference that ClrN and PreN are synchronous signals. Let's see what happens in this case. Now, since ClrN and PreN are synchronous, at the rising edge of the clock, if ClrN is 0, then Q is 0. And if at the rising edge of the clock, PreN is 0, then Q is 1. Let's sketch the waveform for this. Initially, Q is 0. So let's take the first rising edge of the clock. At the first rising edge of the clock, D is 1, ClrN is 1, and PreN is 1. So after a slight delay, output goes to 1. Now, as you can see here, ClrN is going to 0, but it doesn't really matter because they are synchronous signals, which means only at the rising edge of the clock, ClrN and PreN are sampled. And since at the rising edge, ClrN and PreN are 1, your output is going to be just D. So it's going to remain 1 until the next rising edge of the clock. At the next rising edge of the clock, D is 0, ClrN is 1, and PreN is 1. So after a slight delay, your output is going to follow D, that is, it's going to go to 0. Again, PreN is going low here. You expected the output to be 1, but since it's a synchronous system or it's a synchronous signal, it's not going to go to 1 since it's not happening at the rising edge of the clock. So it's going to remain 0 until the next rising edge. At the next rising edge, D is 1, ClrN is 1, and PreN is 1. So your output is going to follow D. So after a slight delay, output goes to 1. Then we have the final rising edge of the clock. At the final rising edge of the clock, D is 1. However, ClrN is 0. If you notice here, at the rising edge of the clock, if ClrN is 0, then Q is 0. So after a slight delay, your output is going to go to 0. And it remains at 0. So this is the fundamental difference between ClrN and PreN being in the synchronous mode versus the asynchronous mode.